All right, let's dive in. Today, we're pulling back the curtain on one of the absolute marvels of modern medicine, the MRI. It's that incredible machine that can see inside your body with stunning clarity, and we're going to figure out exactly how it pulls off that magic trick.
I mean, it really does sound like something out of a sci-fi movie, doesn't it? How on earth do we get a perfect, high-definition picture of your brain, or your knee, or even your heart without any kind of invasive surgery? Well, the answer isn't about scalpels. It's all about physics. And believe it or not, this all starts at a scale you can't even imagine. We're talking about the actual atoms that make you, well, you. And specifically, we're going to zoom in on the most common atom in your entire body, hydrogen. So at its core, an MRI is this brilliant mashup of a crazy powerful magnet and some radio waves. But it's not just about the cool hardware. The real secret is how that hardware gets your own body chemistry to talk to it.
Yep, you heard that right. The real heroes of this whole process are the tiny little protons sitting inside the hydrogen atoms in all your body's water molecules. Just picture billions and billions of tiny spinning tops, all with their own little magnetic fields, just pointing in every which way, completely at random. So how do we get from a spinning proton to a crystal clear picture? Well, it's this amazing four-step dance. First, that powerful MRI magnet acts like a drill sergeant. It fires up and forces all those little protons to snap to attention and align in the same direction. Then bam, a quick radio wave pulse comes in and knocks them all out of line. And this is the magic moment. As the protons relax and snap back into alignment, they release a tiny little energy signal. Finally, a supercomputer listens to billions of these signals all at once and translates that massive amount of data into the detailed picture we see.
Okay, so getting an image is one thing, but doctors need to get the right image. And this is where something called imaging sequences come into play. The best way to think about them is like different camera filters, or maybe different recipes, where each one is designed to make something specific really pop.
And that's why this is so critical. It's absolutely not a one-size-fits-all deal. The kind of information a doctor is looking for will completely change which sequence the technician runs, and making that choice correctly is just essential for getting the diagnosis right.
So let's break down these lenses a bit. A T1 image is amazing for seeing anatomy. It's like a super clear, high-definition map of your body's structures. But switch over to a T2 image, and suddenly all the water and fluid in your body just lights up, which is perfect for finding things like inflammation or swelling. And then you have these really clever sequences like FLAIR, which is a total game changer for brain scans. It actually erases the signal from normal fluid, which makes it way easier to spot subtle problems.
So you've got the mind-bending physics, and you've got all these different imaging recipes. But you know what? None of that matters without some serious human expertise. This is where the skill of the MRI technician is absolutely crucial.
You see, a great scan doesn't just happen by accident. The technician has to be incredibly precise. They have to get the patient positioned perfectly. They choose specific receiver coils, which are kind of like special antennas, for whatever body part they're looking at. And then they plan out the exact slices the machine is going to photograph. So for something like a knee, they'll plan to get images from the side, from the front, and from the top down, just to get a full 3D picture. It's a detailed blueprint for getting a perfect image.
All of this meticulous work is to get this, the clear, perfect image a doctor needs to make a diagnosis. Every single step has to be just right, because if it's not, the quality suffers. And even with the best plan in the world, things can still get in the way.
The biggest villain in the MRI world? It's something called an artifact. And these things are distortions that can turn a beautiful scan into something blurry, confusing, or just totally useless.
So what are they? Basically, think of them like static on the radio or glitches in a video. They're distortions in the image that are not part of your actual anatomy, and just about anything can cause them. If the patient moves even a tiny bit, you get an artifact. A metal implant? Artifact. A technical glitch? You guessed it, another artifact. A huge part of the technician's expertise is knowing how to prevent these from happening.
Okay, we've been talking a lot about magnets and radio waves, and that brings us to what is, without a doubt, the single most important topic of all, safety. Because the M in MRI stands for magnetic, and we are not talking about your average fridge magnet here.
And I really can't stress this enough. Inside an MRI suite, safety is everything. It is the #1 priority, period. There's absolutely no wiggle room on this.
To give you a little perspective on the kind of power we're dealing with, an MRI's magnetic field is more than 1,000 times stronger than that little magnet holding up pictures on your refrigerator. And here's the kicker, it's always on, 24/7. That's why there are some golden rules that are completely non-negotiable. First off, absolutely no metallic objects in the scan room. Ever.
Every single person who enters gets rigorously screened. And if a patient has an implanted device, like a pacemaker or certain kinds of prosthetics, they need a whole special evaluation to make sure the scan is 100% safe for them.
Look, these strict rules aren't just for show. They're there to protect everybody, the patient, the technician, and anyone else nearby, from what could be a really serious accident. All right, so let's take a step back and look at the whole picture we've painted. We started with the wild physics of protons doing a little dance. Then we looked at the art of choosing the right imaging recipe, the technician's skill in planning the scan, and the absolute discipline of safety.
It's just an amazing journey when you really think about it. It all starts with this impossibly faint signal from a single proton. That signal gets multiplied billions and billions of times over, and then a computer translates that entire atomic symphony into an image that can lead to a life-saving diagnosis.
And that, right there, is the magic of MRI. It gives doctors this incredible, unparalleled look inside our bodies, all without making a single cut. It has completely transformed how countless conditions are diagnosed and treated. It's truly a pillar of modern medicine.
It just makes you wonder, right? If we can do all of this today, just by learning how to listen to the whisper of an atom, what incredible new tools are we going to have tomorrow? What's the next great leap forward going to look like? It's something to think about. Thanks for joining me.